This is class 10 of our research and grantsmanship classes organized by the Faculty of Clinical Sciences, Lagos State University College of Medicine. Okay, sorry about that. So I welcome everybody again. Thank you for attending classes so far. We're going fast, so we're going to start quite early. Today's lecturer and speaker is my teacher from long ago. I will always remember him as the one who held my hand when I didn't know my left from my right as a medical student. He's a professor of neurology, and there's so many accomplishments that he's had so far, as you can see from the many appellations after his name. Please welcome with me, Professor Abayomi Ogun.
Yeah, thank you very much, Ronkus, for your kind and very generous introduction. This evening, excited. I've been invited to present this talk on RCTs. I must say that when Ronke first gave me the list, apparently this was missing. I just felt, yes, we should fill in the gap. I'll try as much as possible within the next 1 hour to try to cover this, okay? So, here we go. Good evening, the Dean of the Faculty of Clinical Sciences, the Sub-Dean, dear Provost of the College, other distinguished colleagues, ladies and gentlemen. First, I'd like to appreciate the faculty for inviting me to give this talk on randomized control trials. I make efforts to cover this semester course within a 1 hour time frame, about 50-55 minutes. And of course, we leave time for questions and comments. If we're not able to finish this, then we can always settle out of court or settle on the platform and for any further concerns. First, I'd like to share one slide that reflects how tasking neuro lectures could be. That if you have a patient who never slept for days, all he needs to do is to attend a neuro lecture. Before the end of that 1 hour lecture, that patient will be snoring. I try and not make it so as much as possible. Also remember, this slide was sent by one of my students, apparently the Sub-Dean, many years back. Of course, she's forgotten. But if a single teacher can't teach us all the subjects, then how could you expect a single student to learn all the subjects? Interesting. Well, in terms of the lecture outline, well, I'll try and cover the experimentations, animals, humans. Of course, there's a question that will come in there of who's getting the benefits if you're experimenting with animals. Talk about that in the phase of the study, in terms of the trials, in terms of phase 1 to 4 and phase 0, and of course, phase 5 more lately. And then clinical trials. Why do we do randomized controlled trials? Why randomization and how is it done? Of course, we'll spread it all out. And then classification of the RCTs as well. And always remember this by saying, even PDP, political party, they have house officers as well. H stands for hypothesis. Okay, and when you say hypothesis, you're talking in terms of, is it in terms of a non-inferiority study, or in terms of superiority, or in terms of equivalence, or in terms of benchmark? The O for the outcome. In that wise, talk about the efficacy. When you do considering an optimal and ideal situation, explanatory trials, or talk about effectiveness when it comes to pragmatic, real-life, real-world situation as well. Then, of course, the P there stands for purpose in terms of whether you're looking at the clinical, or you're looking at the community, or looking at the preventive or the risk factors or the cessation. And of course, the phases, phase 1 to 4, which of course I'll spread on that as well. And then now look at the design as well, in terms of, is it a parallel group study, or is it a crossover study, is it a cluster, or is it factorial, or you do a running design, or you do a sequential design as well. We'll go talk about all this. You could imagine within 1 hour time frame. Then, of course, choosing the controls as well. But just to see that not all controls are placebo control. We have negative control, we have positive control, but we have some benchmark control, i.e. comparing with the gold standard. Then allocation concealment, as well as blinding. This is, of course, to minimize bias in the interventional studies. And then, of course, the steps that you have to take when it comes to ROCT. And then, of course, we'll talk about the registration of your trial, the reporting of your trial results as well, the consult. Consolidated standard of reporting trials. Then, of course, quality assessment and the ethical issues. Before I leave this slide, let me say that for ethical issues, I think the sub-dean should also still organize one of the sessions on ethical issues. Maybe the chairman of the ethical committee could look into that. Then, of course, I cannot cover all this within this 1 hour time frame. So one experiment I need to say is the most exacting, a convincing and effective method of establishing causal association. You want to establish a cause-effect relationship, okay? Then you need to experiment. And such studies, they are conducted under many control conditions as possible so that they provide definitive answers to predetermined, well-defined questions. The truth is, the evidence generated by experiments usually is more reliable and of higher level. Experimental epidemiology or experimental studies, of course, similar to cohort studies, except that they involve some action, intervention, and manipulation. AIM. I'll repeat that severally. Cohort studies are just observational. There's no action taken. When it comes to experimental, you must implement AIM. Take some action, some intervention, and manipulation. In terms of observational studies, usually they're seen as descriptive. I could be seen as analytical. Okay, descriptive in terms of time, place, person, and then, of course, analytical in terms of looking at whether it's ecological, whether it's cross-sectional, whether it's case control, or whether it's cohort study as well. But you just observe the natural course, okay? That's what basically you try to achieve in terms of observing the natural course of events. Experimental studies, of course, in about 100 years ago, it was seen basically a study of epidemics using experimental animals, rats, and mice. But in modern usage, it's almost equated to ROCTs. Okay. Also, to state that interventional studies, that the study is carried out under very direct control of the investigator. Well, animal experimentation. Well, in biomedical research, the two fundamental questions that come up: one, are animal experiments morally acceptable? Apologies for saying this in Yoruba. Ushewa lorun entomajewa niboji. Okay, the person working is in the sun, and the beneficiary is in the air-conditioned office. And if we're experimenting with animals, who is benefiting, who is profiting from it? The expected benefit, is it the human or other animals or the environment? That takes us to the second question. So that whatever you're experimenting with animals should have sufficient weight, okay, to outweigh the sufferings of the animals. Having said that, however, that means that if you must do that, then you must be able to justify that whatever experiments you're doing should be well designed, should be well conducted and analyzed, CDA or DCA. well designed, well conducted, and analyzed. Well, the question I've raised actually appears scientific rather than just moral. Okay. However, if you do not appropriately design, conduct, and analyze, the results which you produce, they're not likely to be reliable. Okay. In other words, you would have wasted the lives of the animals. So whatever it is, the suffering or the use of the animals should not counterbalance the benefits in terms of science, in terms of benefiting human health. Okay, that's important. Well, this third question has actually been addressed by earlier speakers during the course of these sessions, i.e., the systematic review, study of studies. Okay, Mr. Adewumi extensively dealt with this, and I think other earlier studies as well. And I think on that note, I just feel I'm going to fly through some slides now. They're not my real direct ones, so I don't take care of the much time I need for this. Well, before I leave this as well, there's also something we used to say in those days, okay? Kòkòrò tí gbé ẹsẹ̀ sí apá kan, kòkòrò tí wọ̀ ò lè dá. Okay, that don't kill that ant, okay, since you cannot create the hand. Then what do we say? I mean, Ileya, the Eid al-Kabir is fast approaching. What happens to the animals? Anyway, that's just a side attraction. So back to systematic review, and I know a lot of questions were raised during such sessions. So what I've done basically is just to give some tables for comparison. And I'll leave this for what the slides will be shared. Looking at literature review, narrative review is seen as expert opinion, traditional, what have you. Systematic, they're all seen as reviews or overviews. And then when you now subject the systematic review to statistical analysis, they talk about meta-analysis. So this is just talking about all they have said before: narrative, traditional, expert review, subjective, systematic review has been extensively dealt with. And the table trying to compare traditional review, meta-analysis, systematic review. This systematic review and literature review, again, it's been well covered. I mean, number of authors, 6 to 12 months, amongst others. And then systematic review and narrative review as well. And then scoping review. I remember Professor Njokama asked a question between this and systematic review. Basically, just to say, it's a precursor systematic review, and tries to identify and analyze some knowledge gap. They will be scraping, digging, and shoveling as well. They will also try to classify some key concepts and definition in the literature. And if one looks at this, I mean, if you have raised your question that you want to treat, do a scoping search, then the protocols, full research, then get it title and abstract training. They can then proceed from there. That's not my focus for today anyway, just for keeps for the records. So now, getting back to course. So what is the aim of RCT? A scientific proof of etiological or risk factors which may permit modification or control of diseases. Well, as health practitioners, one of the things we intend to achieve is to be able to prevent and control and treat diseases and improve the health of the community. I mean, for the community physician, we'll say this more. And this, of course, brings us to two key terminologies which we need to be aware of. Efficacy talks about effectiveness, okay? That is the degree to which something is successful, or the ability to produce a desired intended result. It's like a kind of a ratio of an overall benefit vis-a-vis the risk-cost assessment. We're talking about efficacy or effectiveness. Let's take NSAID, for instance, non-steroidal anti-inflammatory agent, ibuprofen, or whatever, and paracetamol. Of course, they both have antipyretic effect, they have an analgesic effect. But you can want to compare in terms of which one is more efficacious, which one is more effective. In other words, the overall benefit vis-a-vis the risk-cost assessment. Then efficiency. I mean, that's the state of quality of being efficient. Relates to the useful work vis-a-vis total energy expended. I take this, I have to go back to Ikorodu, and I have 2 vehicles. In one I buy 10 naira fuel, the other one I buy 5 naira fuel, and I'll get there. Of course, the one that will save me less costs, okay, may be seen as being more efficient. And I also take this to also assess between the community physicians as well as the clinical physicians, as it were. In other words, those of us in pediatrics, in medicine, in surgery, and obstetrics and gynae vis-a-vis community physicians. I gave my inaugural lecture 2009, about 15 years ago. And one of the submissions I did there, which I still achieved, was to recommend Masters in Public Health for all clinicians. What was the rationale for that decision? I looked at a community, okay, a very big city. There was a very high hill there. And at the bottom of that hill, there was a stream at the bottom. And the inhabitants of that city, they kept falling into the stream. We as clinicians, all we were doing then was to wait to fall inside the stream. If they were babies, they see the pediatricians. If they had adults, they see me. Or if they had a fracture, they see the surgeon. Or they fell in labor, or what have you, they see the O&G people. In terms of efficiency, I mean, that was not it. You know what the community physicians did? They went to that on top of the hill, and they were able to barricade, and they did all whatever they need to do to prevent people from falling inside. So you can assess the efficiency vis-a-vis clinicians on one side and community physician on the other side. So kudos to them. So let's get back. Classification of epidemiological studies. Observational studies, I've mentioned that, could be seen as descriptive and analytical. Descriptive studies in terms of time, place, person, okay? I look at stroke, for instance, okay? It's common in the elderly. It's also common in the black skin as well. Common in male, just trying to describe what have you. And of course, more severe as well. Then in terms of analytical studies, look at the ecological, look at the cross-sectional, and also look at the case control, and then look at the cohort as well. Cross-sectional, we're making reference to a specific point in time, okay? And I go to today, Tuesday, we're running the neuro clinic, and I go in there, how many patients there came in with stroke, how many came with Parkinson's. I mean, that's a specific point time reference. That's cross-sectional. If I look at case control, well, I look at, I mean, those, that's over the time frame at the community. I look at those who came in with the disease or the outcome of interest. Okay, and those who did not have the outcome of interest, like when COVID came around, for instance. Then you now want to retrospectively, want to look backwards to see the frequency of exposure or to the risk factor that's led to it. Okay, so it's like you're looking backwards. You have the cases, you have the control, and you're looking backward to what they were exposed to. Okay, cohort study, of course, you still have the unified population, and then you're now looking at the outcome, okay, or the variable of interest, okay, and then you now see, you're looking prospectively, you're looking forward to be able to assess that. Then, of course, you have the experimental and interventional studies, and then the RCT, which I think is the topic for today. And then, of course, field trial, community trials will come in as well. From a population based on one or more variables of interest at one specific point in time, whereas case control looks retrospectively backwards, and then cohorts looks prospectively as well. So looking at it more closely is to simply say that the direction of data collection, okay, you're looking at that vis-a-vis the onset of your investigation. Okay, trying to time the data collection vis-a-vis the occurrence of outcome of interest. So present, this is cross-sectional. Case control, you're looking backward, those who had it and those who did not. What risk factor were they exposed to? And what prospective, of course, that's the cohort. You're looking to the future to see those who will come down with it and those who will come down without it. This, of course, is evidence-based medicine, and you have this pyramid. Okay, at the bottom of the pyramid, you could talk about your laboratory, your in vitro testing, talk about animal studies. There are no humans involved. And then, of course, you now involve the human. You start with your case reports or case series. Usually we say 1 case is interesting, 2 cases noteworthy, 3 cases worthy of is reportable, interesting, noteworthy, and reportable. Then, of course, you could extend that further. Your narrative review or traditional review, your expert opinion will come in there, or editorials when you make submissions. Beyond that, of course, you have your cross-sectional study, which is missing here. Then you have your case control, then you have your cohorts, then you have your RCT, which I think is the main topic for today. Well, this, of course, observational studies done, this, of course, they're all primary studies with the RCT. Beyond this now, you can now do study of studies. That's your systematic review. And then now further, you can subject this to statistical analysis and then do your meta-analysis. So I didn't want to cover all this at the last session. It's from this then that you can now have the clinical practice guideline emanating from this. So those are secondary or pre-appraised or filtered. So you could even become a professor if you keep doing secondary study. Just keep doing systematic review and meta-analysis. But be sure that it must be multi-authored. Just saying it in the same way, in vitro test tube, animal research, your ideas, opinion, case report, cross-sectional, case control, cohort, RCT, increasing evidence strength. I feel that's the position in the evidence of hierarchy. And then when it comes to generating hypotheses, vis-a-vis established causality, of course, you have to move from the bottom to the top of the pyramid as well. And just to let us appreciate the level of evidence, starting at the bottom, of course, expert opinion, and then you have your SR and what have you towards there. Okay. So, what are the phases in the study of drug or vaccine development? Evaluation. I need to say that for phases, really phase 1 to 4. We're very familiar with that. Phase 1, of course, you're doing it on elderly population. And then you're looking at 20 to 100 subject, elderly population. We're trying to assess the safety, trying to assess the efficacy, as well as the side effects. And then, of course, so SES, safety, efficacy, and side effects. Then, of course, phase 2, those are carried on disease group, okay? Usually between 100 to 300, assessing the same safety, efficacy. Of course, it's done in multiple centers as well, but those are in diseased subject. Phase 3, which I think is the equivalent of the RCT, okay, it's carried out in thousands, 300 to 3,000 of people. And then you study the safety, efficacy, fitness for manufacturing, and you determine the effectiveness, which we had mentioned, or efficacy, the overall benefits vis-a-vis the risk-cost assessment. You could compare the new treatment with a placebo or a gold standard, usually with a gold standard. And then, of course, ethical approval and the like will come in. And then your phase 4, which is the post-marketing surveillance study. Usually it's non-randomized, and then pharmacovigilance will come in there as well. Of course, the whatever mutation must have gotten approval, the regulatory body. Then going beyond this, phase 0. This is a recent designation, and usually talks about human microdosing, and the usually number of subjects are between 10 to 15. We're trying to assess the pharmacodynamics and the pharmacokinetics in such patients. Phase 1, just to blow it a little more, the early volunteers, It doesn't qualify to be called a clinical trial. And then, of course, you could use a larger dose than the phase 0, so that you could look at the maximally tolerated dose, 20 to 100 healthy volunteers. Okay. Then phase 2, of course, between 100 to 300, and you're trying to estimate the rate of adverse events as well. And there could be 2A and 2B. 2A assessing the dosing, then 2B assessing the study efficacy. Phase 3, which I think is the RCT, this is based on a larger population of patients, usually between 300 to 3,000, is a definitive assessment of efficacy, okay, which of course relates to the fact that most of your clinical studies, you're assessing the efficacy, and then of course effectiveness of the intervention or role in clinical practice, more of community-based efforts as well. Well, it's quite expensive, time-consuming, and but then it must be designed and conducted and analyzed to a high standard, and of course with precise quantitative results on safety and efficacy. Then phase 4, that's the post-marketing or surveillance study, and usually it doesn't involve any control group. It's non-randomized. It's just to be able to detect any rare or long-term adverse events on a larger patient population time scale. Well, some of the old schools in this faculty, okay, must have survived the thalidomide that came in the 1950s. Okay, thank God our mothers did not take at that time. Otherwise, some of us might have fucomilia or could have been otherwise. Then I cannot bear to talk about phase 5 as well. And I remember, when COVID came, we all had cause to use hydroxychloroquine amongst others. Okay, phase 5 actually relates to medications that were accidentally discovered, what we call serendipity in science, and was a chance finding. And everybody will agree with me that hydroxychloroquine, had gone through safety, efficacy, and side effects, whatever, before now. So when you have such a repurposed medication, like we did a mouthwash study, chlorhexidine in patients with COVID. Of course, that was not the primary use, but of course we found it useful in such. So that would be like a phase 5 trial that we have done. So it's like a repurposed IMP. IMP means investigational medicinal product. So clinical trials overlaps between efficacy, effectiveness, between stage phase 1, 2, 3, 4 as well. So clinical trial, how is the clinical trial defined by WHO? Well, it's seen as any research or any biomedical or health-related measures that prospectively assigns human beings or participants or groups of humans to one or more health-related interventions, AIM, remember that all the time, action, intervention, manipulation, that it can evaluate the effects on the health outcome, and then some pharmacokinetic measures and adverse events will be appreciated as well. A lot of trials, the RCT, the late 40s, early 50s, particularly Sir Austin Bradford Hill, with reference to the use of streptomycin in the treatment of pulmonary TB, okay, is credited as having conceived the model of RCT. So the clinical trials, basically, they're classically prospectively planned experiments, and for the purposes of evaluating potentially beneficial therapies or treatment, and is designed to evaluate efficacy of drugs or the clinical procedures. Most common, of course, is the randomized double-blind. When you say double-blind, the patient doesn't know, the investigator doesn't know as well. There has to be controlled clinical trial. I'll blow that up in a couple of minutes. Of course, usually multi-center trials, which is conducted in more than one center and also multi-authored as well. And there is also that you could recruit necessary number of subjects within a reasonable time frame. If you have it multi-center. and you have more representative sample of the study subject. And of course, those other investigators that have similar interests and skills to work will be able to solve a common problem as well. Having said that, of course, evidence from this generated is more valid. Okay, it has internal and external validity as well. When to conduct clinical trials? That's a big question. There are three aspects to this. The first one talks about when there's sufficient evidence for its safety and effect. We must remember the ethical principle, which we remember readily by saying JAMB. J-A-M-B. J for justice, A for autonomy, M for non-maleficence, and then B for benefits, okay? So the first one talks about non-maleficence, okay? You need to ensure that there's evidence of safety, and of course effect as well is also relevant. And then two, when the benefits supersedes the risk, okay? In other words, of course, it's beneficial, to the patient. Okay, the benefits supersede the risk. Then, of course, there must be clinical equipoise, i.e. predicaments vis-a-vis uncertainty by experts in that field. Okay, there's a clinical equipoise so that you can justify why you have to do this stuff as well. The types of clinical trial, of course, we could talk about the randomized clinical trial, which is the topic for today. We also have non-randomized clinical trials, which are not controlled, okay? So most clinical RCT, they're governed by chance, and the randomization in there is seeing allocation of individuals to groups by chance. Each sampling unit has the same chance of selection. A mixed intervention and control group makes them comparable at the start of the investigation, okay? You have to be comparable so that at least you're comparing orange with orange, apple with apple. RCT basically talks about an epidemiological experiment in which subjects, okay, in a population, they are randomly allocated into groups called study and control group. Well, I must say the word study group, a lot of other synonyms that one could look at. Well, it depends on the school of thought where you belong to. Or even the controls, you're also studying them as well. So that's some arguments that way. So you really should not say just study. The other words you could use, you could say, the interventional group or the experimental group. Of course, the control are also experimented on as well. Or you could put them as the subject or as the cases or as a treatment group, okay? So with treatment group versus the control, or cases versus control, or subject versus control, interventional or experimental versus control, rather than the word study group. Again, and of course, you're going to apply your AIM, your action, your intervention, manipulation, and whatever you're using is an IMP, investigational medicinal product, so that I can evaluate the safety, the benefits, amongst others. And they compare either the new IMP with a matching placebo, or we could do with a gold standard, okay? With RCT with double blinding, of course, is top-notch, okay? So let's go further. So RCT, you need to randomize, okay? Well, I have 10 patients here, and all of them are above 80 years old. They have diabetes, they have hypertension, they are dyslipidemic. And I feel strongly, of course, taking aspirin, clopidogrel, they're not for primary prevention, more secondary, okay? However, if you have an existing individual with such comorbidities, I think you may be justified to empirically. And I did in some of them. The treatment group and the control group, of course, they were 5-5. And then when you follow them up, 3 out of the 5 here developed left hemispheric infarctive stroke, whereas in the treatment group, only 1 developed. Okay, so might be proven to be so. So your randomized trial, study population, you randomly assign them current treatment, new treatment, improved or not improved, because you have to follow them up. Randomization is the key feature and is the heart of RCT. So we need to know how to randomize. Okay? Randomization ensures that each participant a known chance of being assigned to any of the groups. And it's important because overall it provides the strongest evidence for a causal inference. Okay? So 3 keywords must be emphasized in here. Randomization, so that you can eliminate bias in selection and also allocation of your treatment or otherwise. And then you also balance all the confounders. The confounders, some could be known, some could be unknown, and some are inherent. You need to have this at the back of your mind. And then, of course, we'll see in one of the designs, okay, where you have a crossover in which even the subject is even serving as his own control as well. Of course, it has its other minuses too. Then control in terms of the intervention vis-a-vis the control, and then the control, of course, is either active or the placebo. And then also remember that you can have positive placebo, you can have negative placebo, and then you could have, then you need to ensure, of course, that both groups are identical, just like you've seen there, except for the intervention. Of course, that's why it's experimental. You have some control over the process. And then with such experimental intervention, AIM, your action, intervention, and manipulation. And then, of course, you don't know what the effect will be. I mean, because that will be your dependent variable that you're working out from an independent variable which you're applying. Randomization. That's the allocation of subjects to treatment group is left to chance or randomized, or randomness, rather. You attempt to eliminate bias and allow for comparability, okay, orange for orange, apple for apple. The major purpose is that so that the study groups, they're comparable on baseline characteristics, okay? You try to balance the prognostic factors as well. More or less, confounders, they get equally distributed between the two groups. Of course, selection bias in allocation to group, and then you also it also facilitates double blinding as well. Intervention will exhibit a real effect, and even measurement of the outcome variables as well makes it easy. Yeah, now one of the things you could do is to do a random assignment. Okay, flip a coin. I mean, if this is the head, okay, then if it's the head, okay, that means treatment A, and if it's the tail, treatment B. On a lighter note, I could just say that I'm presently making this presentation from Basel in Switzerland, and I could say, oh, fine, I have to spend euros here. So if it's head, the dean, the sub-dean, I will send 1,000 euros to Professor Ogun. If it's the tail, the attendees, okay, will send 1,000 euros, of course, to Professor Ogun as well. However, the third one, if you flip the coin or toss the coin and it stands on its edge, the Professor Ogun is promising everyone here will send 1,000 USD to everyone. So that's just on a lighter note anyway. Then you could roll a 6-sided dice as well. If it's even number, take treatment A. If it's odd number, take treatment. Simple randomization, just like tossing a coin, which head, active, tail, placebo, okay? I haven't said that you can have an imbalanced randomization, okay? It can happen. You are reducing the statistical power. So in a trial of 10 participants, instead of the 5-5 split, okay, you could have, so a split may occur in such a case. So going beyond that, we could talk of block randomization, okay? This is, and then you need to balance this within each block. So if you divide potential patients into n blocks of size 2n, okay? Let's imagine I have 24 patients, and I want to divide them into 6 blocks, okay, or 4 in each block. And then, of course, you could put your AABB or BBAA and whatever. So at least then you choose the blocks randomly, such that each of them, they go to that block. You could do this on your clinic day. Maybe the first 4 that come could be in one block, next 4 another block, or whatever. Just at least to put some randomization, and then the sequence of who takes the active, who takes the inactive, or the placebo come in there as well. Stratified randomization, RCT may not be valid if it's not well balanced across prognostic factors. I cannot be comparing stroke in the very elderly, 60 and above, with stroke in the young, 15 to 45, okay? Or comparing males with females, or what have you, okay? So you need, in such a case, you need to balance the subject on the baseline covariates, okay, and produce comparable group with regard to certain characteristics. The gender, the age, the race, the black skin and the white skin. Our own stroke is more severe. Outcome is also poorer as well. This has been established in several studies. And also, of course, about 15 years earlier as well, compared with the Caucasians. Then the disease severity. So you need to produce a valid statistical test. And then, of course, the block size, of course, should be relatively small so that I can balance in the small strata. So let me give an example of what I've said in here. You have 1,000 patients and you need to stratify by sex and by age. When you did by sex, you have 600 males, 400 females, and by age you are 360 young, and then you have 360 young, and then you have 240 old, okay? The same for 400 females, 300 young, 100 old. So of these 360 young, you're going to subject them to new treatment and old treatment. So you divide it by 2, that gives 180. 180 for the old, divide into 2, 120, 120 there. So at least you balance all the covariates. That's stratified randomization. Now don't forget, you can also do computer-generated list as well, okay? And you could use, this of course is best in terms of you could use the date of birth or even or number of the hospital records and then the dates at which they are invited, okay? Also even as well. You could do some random numbers, and then some are also part of random numbers as well. So how do we classify RCTs? I already mentioned that the HO for the PDP, on the basis of the study design, on the basis of hypothesis, on the basis of the outcome of interest, and then on the purpose, and then the phases of the study. Design of RCT, of course, you need to put a reference or a target population, and then you take the sample from there. And then, of course, those who are not eligible, you have your inclusion and exclusion criteria. Those not eligible, they're down. And then those who do not wish to give consent, but they must give consent. And then thereafter, you can randomize, okay? The experimental, the control, the manipulation or AIM, action, intervention, manipulation, and then you follow them up, and then you assess. This is saying exactly the same. Select a suitable population, and then the sample from that population. Exclude those that are not eligible, those who don't give consent. Then randomization, interventional control, your AIM, and then your assessment as well. So you must compare like, okay? So that at least that's a way. I mean, those who receive and those who do not receive, they must have a lot of things in common. Then in terms of the clinical trial design, the parallel design, that's what we're all used to. A will take, group 1 will take A treatment, group 2 will take B treatment. That's parallel design. The crossover design is such that both group 1, group 2 will take both treatment A and treatment B, but at varying times, and there must be a washout period. Sequential design by Armitage, sequential analysis, okay? In which case, patient will just keep taking the medication, or you keep drawing your graph. If it cuts below a particular line, then of course you have to drop and stop. Okay, you can apply the stopping rule. If it keeps going up and crosses the superior line, then of course you can also accept. Then cluster randomization, which is more based into maybe convenience amongst others, where you have group of either school. You could use school A for this, you could use school B for another one, or village A for this, village B for that, but they should be distant so that there's no cross-contamination. However, I mean, some polygamous setup, you could have man A, okay, has one wife in village A, even village B has another one there as well. So they're closely based on cross-contamination. Running design such that you try the patient to see if they will be compliant with your medication. Okay, you could start with placebo or whatever. If you see they're not compliant, then you can drop them in between. And then your block randomization, we've talked about that as well. So just spreading it out a little bit. Parallel group, each participant is randomly assigned to a group, and all participants in the group, they either receive or do not receive. Then crossover, over time, each participant receives or does not receive an intervention in a random sequence. Okay. Then cluster, you have a pre-existing group of participants in the village or the schools, and they're randomly selected to receive or not to receive. Then factorial, that's also randomly assigned to receive a particular combination, like you have a vitamin X, vitamin Y, and each of them has their own placebo. There's placebo X, placebo Y. Okay, and then you have to do all this all at the same time. That's factorial design. So let me just show diagrams as it relates to all this. It talks about this is the parallel group, treatment group A, treatment group B, treatment, and then each one there you then compare as well. Still talking about the same new treatment, current treatment, improved, not improved. Okay, this is still just a parallel design. For the crossover study, this is group one, okay, and then there will be a time for elimination, a washout period. The washout period needs to be mindful of the half-life of whatever medication you are giving, and then of course crossover to group 2. Of course, that's the advantage because the subject is actually serving as its own control as well. So it could be, except that it could be cumbersome in a way. This is still saying the same thing: the experimental group, the control group, the outcome. Then there's a washout period, and then you again as well. It has its advantages. Of course, each patient receives both, so patients are contented in a way. They're going to profit from it. Of course, it's going to take a longer while. You need a smaller population since the control is also part of the subject is the control as well. There's a carryover effect. In acute cases, not visible, but in chronic stable cases, unlike in the parallel group. Okay. Of course, this is of shorter duration as well. A group are assigned to different. Of course, the advantage of crossover, well, is influence of co-founders. Okay, will be reduced because this is the same subject who is the control. However, there could still be a caveat. I could have a febrile illness during the course of water, even if I'm the control, that may influence, but that's not pretty common. Of course, the patient also, they're really reassured in a way. They want to give consent because they know at one time or the other they will receive the new treatment as well. So they're kind of happy. However, it's not suitable if it cures the treatment. Like wants to check for anti-malaria, and patient are taking the one that taking care of the malaria. Of course, you won't see any effect thereafter. Okay, and then certain stages or when you have a rapidly changing condition, the use of other effects, okay, is also necessary, and the wash period. Factorial study design. I've already said that you have more than drug A and drug B, and each of them has its own placebo. So you have 4 possible treatment groups. Like you're combining bipilurate with vitamin E. HOPE study, for instance. Okay, ramipril placebo. That's the first one. Then vitamin E placebo as well. So 4 groups will therefore be one with ramipril, vitamin E, only vitamin E, ramipril only, neither ramipril nor vitamin E. It has its own advantages because it's going to be cheaper relatively, almost the price of one. Okay, you can achieve 2 what have you. And of course, you must have 2 different mechanisms of action. The disadvantages, however, complex statistical analysis, potential for adverse effects, recruitment and adherence issues, and then of course, the gain in cost. You need to compare it with the complexity that you may have. Possibility of interaction needs to be mentioned. Cluster on randomized trial when you have clinics and communities. Okay, I'm doing a rate study. I could give to some in Lasut. I could give to those in Lut may not have the medication. So it's kind of convenience, I mean, in a way, and even in the village as well. Okay. Cluster randomization, of course, you need to avoid group contamination. That's its advantage. If you take two different set of villages that are distance apart, except for polygamous guys, that could make some contamination as well. The logistically more visible, of course, I mean, it's still within your purview. Or you want to do a study, we run 2 clinics on neuro, Tuesdays and Fridays. I could say, look, those on Tuesday clinic, I mean, they can do a cluster randomization on them. They will take treatment A. Those that come on Friday will take treatment B. Okay? Then the running design. Usually you screen and consent. Once you get that, if during the running period they're able to comply with medications, what have you, if otherwise, then they don't go further. You just drop them at that level. That's the running design. Non-compliance may seriously impair efficiency. So you want patient that will, of course, will comply with whatever medication you're giving. Yeah, this is the sequential analysis by Hermitage, which, of course, what you're looking out for is to keep randomized the subject until the null hypothesis is either rejected or accepted. Okay, once it crosses the lower hand, that means treatment is worse, and then, of course, you can apply your stopping rule. Okay. I think I did this study on dexamethasone in stroke for my dissertation, I think in the 80s. Yes. Okay, that was in Lut then. Okay. So once it crossed, we were able to establish that, because as you have a positive effect, the graph will go up, negative, it goes down until it cuts the lower down. In terms of the hypothesis, okay, you need to look at what do you want to prove. You want to prove superiority, equivalent trials, or non-inferiority. Okay, you must make up your mind what you want to do. Well, non-inferiority is what most people will go for anyway. Superiority, usually, of course, you need to compare with the gold standard. Okay, non-inferiority study aims to show that the effect of the new treatment is not significantly weaker in any way. Okay, and it's not. And the equivalence, okay, could be a little bit difficult, but if you be able to compare, let's say, paracetamol, NSAID, and the same efficacy, then you need to look at factors that will say, oh, which is less expensive, which is better tolerated from an ulcer patient, which is more easily administered, a phobia for injections, so I prefer if an oral will do the same as well. Okay, trial with positive control. Treatment is as good as current, well, 51 minutes already. Okay, I'll just comb round the rest. In terms of the outcome, okay, efficacy trial comes in. Okay, when you talk about efficacy, you're looking at optimal conditions. Okay, and then explanatory trials. And when it comes to effectiveness trial, you're looking at pragmatic, the real world situation. Okay, real world condition for effectiveness, efficacy for ideal, optimal conditions. This is just saying the same thing: explanatory for efficacy, pragmatic for effectiveness. That's the real world, more flexible, usual conditions as well. So the types of the controls are comparison group, and what you're trying to do is to evaluation of the benefits, the types of control, types of blind, all become relevant. So what are the types of control? You have negative control, you have placebo control, you have positive control, you have benchmark trials. Benchmark, you have the gold standard, and you're comparing with that. Positive control, even the placebo, maybe taking a positive one as well. And then you have the negative control. A quick one, the benchmark, of course, that's the gold standard. Positive control, the taking something beneficial, even if you're comparing with yours. Negative control, in such negative control is type of commonly employed to determine whether an agent provides activity over and above its vehicle. Okay, the case, of course, is to consider the 4% Tulsi mouth rinse. But of course, the Negative control will be devoid of thoracy. Placebo control, just an inert substance. That's all you have there. And then, so in this study, it's an herbal toothpaste. You could have a positive control, which will be fluoridated, contain fluorine toothpaste. And then the placebo will just, without any added ingredient. The negative control will almost be the same as herbal tooth without the herbal ingredients. Then blinding. Well, you need to do blinding. Of course, you have unblinded trials. Most surgical procedures, they are unblinded. Stringent precautions need to concealment of groups. Patients are not revealed prior to definitely allocation to the respective groups. You need to prevent selection bias, okay, and do allocation sequences. The standard method is to use the SNOs, the sequentially numbered opaque sealed envelopes, okay. Then you have non-random systematic allocation as well. Why do you do blinding? You want to reduce the following: subjective judgmental bias, information bias as well, investigator, patient bias, statistician bias, interpretation bias. Single blind, the patient doesn't know. Double blind, both the patient and the investigator, okay, neither of them know what is happening. The triple, your data analyst, okay, is also not aware as well. And then some use the word triple and quadruple. In the triple, the trial administrator, some research studies, they have trial administrator, they also do not know. The quadruple, the data analyzer too doesn't know as well. The types of RCTs, I have to fly now, 5 minutes. Clinical trial, preventive trial, risk factor, cessation, community intervention, application of your RCT, okay? Preventive trials, I'll just fly through the risk factors, cessation experiment, trial of etiological agents, community intervention trial. So the steps of conducting RCT. You need to draw a protocol, selecting your references, and then randomization, your AIM, follow-up, and assessment of outcome. A lot of statistical analysis in there, which I won't go into. Drawing up your protocol. You need questions to be answered. You need to have your research question, the criteria for selection, your study design, selection of your study, and the control, and the when, where, and how to apply your standard operating procedure. You need to do all that. Then select your reference and experimental population as well. Where do you want them to be, educational group, and what have you. Some same characteristics and reference point as well. Okay, your action, your type of intervention, your AIM is the independent variable, and then the outcome will be your dependent variable. Then you need to follow them up, and then you need to define the intervals of time in a standard manner with equal intensity and under the same given circumstances as well. Then don't forget attrition about 10%, because you may lose some of them from death or the JAPA syndrome, migration or loss of as well. Assessment of outcome, that's the final step. Rate of outcome, all this has to do with either you get a positive effect. Yeah, my time is up. Either you get a positive effect, okay, in which you reduce the incidence, severity of disease, the cost to health workers, or the appropriate outcome, or a negative, more severity, more complications, more death as well. Endpoint clinical measures, you need to look at hard endpoints or the surrogate endpoint. Okay, surrogate, when you talk about biomarkers, then the hard endpoint where you are able to you're able to either confirm maybe death or some disease entity as well. Then the relative risk, okay, that's applicable to cohort studies, odds ratio applicable to case control. So this is the hard endpoint, clinical endpoints, patient death, or a biomarker for surrogate endpoint, your HbA1c, serum cholesterol, and renal disease, or whatever. Your assessment, I need to do all this. I have to fly through this and go to analysis. That's advantages and disadvantages of RCTs. Randomization tends to balance prognostic factors. Detailed information can be collected on baseline to dose level. Blinding of participants is also essential. Disadvantage is subject exclusion. Strong criteria may limit your generalizability. Okay, like if you excluded black skin in your stroke patient, for instance, that could limit generalizability. A long period of time. Then a large offer, it takes time. Of course, financial cost is also the ethical concern as well, except you do the sequential analysis and apply the stopping rule. A large number of usually employed. So there's some biases, which I think I'm going to round up now. Biases, selection bias, confounding imbalance. The Orton effect, okay, is also essential. I mean, just to know that you can have a psychological benefit. But the patient feels, oh, I'm receiving something, okay? Or just even the awareness that I'm being observed is enough to give some euphoria. It's different from the placebo effect, okay, which is actually both physiological and psychological, regardless of observation or what have you. We have observer bias as well. The outcome. Summary: assess for eligibility, enrollment, allocation, okay, then the follow-up, and then the analysis, okay, and then you discontinue. I mean, some will be lost to syndrome amongst others. So in conclusion, it's a well-conducted double-blind RCT, gold standard of research design, studies of efficacy, will minimize bias and maximize the potential for attribution and credits. Individual patients are randomly allocated to receive experimental or standard, and they maximize good internal validity. That's very established. We lack generalizability, okay, can be called as well. Where the lecture is over, I think notes. I'd like to thank everyone for your attention, your time, and everything. And just finally to say the quality assessment, which I said, check scoring. We don't need this for this session. Okay. Ethics, of course, I've told Dean, may need, or the sub dean, they may need to as well. Okay, those are my references. And I end with this by saying, if